Hello everyone. Today we're going to discuss how to multiply rational expressions. Let's begin with this problem. 3/5 times 10 over 9. Now to multiply these two fractions, which are rational expressions but very simple ones, there are two methods. The first method is to multiply the numerators and the denominators, which would give us 30 over 45, and then completely factor the numerator and denominator to 3 times 2 times 5 over 3 times 3 times 5, and divide through divide through a factor of 1. So here our answer is just 2/3. That's one way to multiply rational expressions. Another way is to completely factor from the beginning. So we'll write this as 2 times 5 over 3 times 3, and then divide through the common factors that appear in both the numerator and denominator. So we could divide through a 3 here, we could divide through a 5 here, and we see that our answer is 2 over 3. So in the second method, what we do is, by factoring, we divide through the common prime factors that appear in the numerator and denominator. And we do the same for rational expressions like this one. Let's say we have x plus 3 over x minus 4 times x squared minus 2x minus 8, all divided by x squared minus 9. So if we use method 2, this first fraction, there's really nothing to factor, but in the second fraction, we could factor the numerator into x minus 4 times x plus 2, and the x squared minus 9 is just x plus 3 times x minus 3. So now we try dividing through the common factors, and we notice that we have an x minus 4 here and an x minus 4 here. That's a ratio of 1. An x plus 3 here and an x plus 3 here. That's another ratio of 1. And the result is just x plus 2 over x minus 3. At this step here, we should write the restrictions of the variable, and the restrictions for this variable x, if all of those denominators are 0, is that x cannot equal 4, -3, or 3. And that is true for the final answer. Okay, so to summarize, let's summarize this, how to multiply rational expressions. So to multiply rational expressions, we factor all numerators and denominators completely. Okay, now at this point, write the restrictions for the variable by setting all the factors in the denominators to 0. Okay, that should be done right away. Then we divide the numerators and denominators by the common factors. So we divide through the common factors that appear in both the numerator and denominator. Okay, and then multiply the remaining factors in the numerators and the remaining factors in the denominators. And in this step 4, do not distribute, leave in factored form. So leave answer in factored form, which I will demonstrate in the next problem. Okay, so let's copy the next problem and let's follow the guidelines listed on the previous page. So what we'll do is we'll completely factor everything. In the first numerator, we could factor out a 5 and get an x plus 1. And in the second one, we could factor out a 7x, so we get 1 minus x. And for 2x squared plus x minus 3, well, we know that the factors have to be 2x and x. And if we want the inner and outer terms to add up to a 1, the correct placement would be a plus 3 here and a minus 1 there. And the 4x squared minus 9 is just 2x plus 3 times 2x minus 3. So at this point, we could write the restrictions for the variable. X is not equal to 0 if we set 7x equals to 0. X is not equal to 1 when we set 1 minus x to 0. X is not equal to negative 3 halves. And x is not equal to positive 3 halves. All right, now we divide through. So let's see now. Well, we have a 2x plus 3 here that exactly matches. But notice here we have a 1 minus x and an x minus 1. And from the previous lesson, we know that anything in the form of a minus b over b minus a, where a is not equal to b, is negative 1. So let's all agree to put the negative 1 up there. Nothing else divides through here. So when we say leave the answer in factored form, we mean the following. We multiply the 5 by the negative 1. I'll make this negative 5. Carry down the factor of x plus 1 over 7x, which remains in the denominator, times 2x minus 3. And this is the answer in simplest form. Note there are various ways to represent this, but do not distribute. Leave your answer just like this. Okay, so now that we've done that, I'd like you to try one yourselves. Okay, so copy this problem down and try it by yourself. Pause the video. Okay, so to do this problem, in the numerator we could factor out a 4 and get an x plus 2 here. In the denominator we could factor out a 3x, so we get a 2 minus x here. This factors into 3x and x. And the correct factorization there, well, the factors of 4, I would try 2 and 2. So if I put a 2 here and a 2 here, I want my linear term to be negative 4, so I'll make the 3x times 2 negative and that positive. And the other difference of two squares is just 3x plus 2 times 3x minus 2. And in a similar way, these divide through to a 1, and these divide through to a negative 1. So I'll put the negative 1 up here. And nothing else divides through. So the answer should be negative 4 over 3x times 3x minus 2. Let's just make an agreement that if we divide through a negative 1, we'll put the negative in the numerator. So this way our answers look alike. So we'll end our lesson with this final problem, which I'd like you all to copy and try yourself. So pause and then replay when you're done. Okay, the most difficult part in this problem is the factorization. So multiplying rational expressions is a great review on how to factor polynomials. So in the first one, 10a squared plus 13a minus 3, well, we could use brute force, or we could look at that and ask ourselves, using the AC method, which we discussed in class. Let me just get this down here. So if we have 10a squared plus 13a minus 3, we multiply the 10 by the negative 3, we get negative 30, and we have to find two factors of negative 30 that add up to positive 13, and I believe that would be positive 15 and negative 2. So we rewrite this as 10a squared plus 15a minus 2a minus 3, and use factoring by grouping. So we factor out a 5a, we get an a minus 3, and then, a 2a minus 3, and then minus another 2a plus 3, I should say, and minus a 2a plus 3. So the final factorization is 5a minus 1 times 2a plus 3. If you couldn't get the factorization, you could always use the AC method. Okay, now the factorization for 3a squared minus 8a plus 5 is 3a minus 1 times a minus 5. And I believe that works. To factor this top one, this one here, I have the work here. So I did factor by grouping. I factored out an a and a negative 1 from the second 2, and the factorization's a minus 1 times 2a minus 3. 25a squared minus 10a plus 1 is a perfect trinomial square, 5a minus 1 times 5a minus 1. To factor the 15a squared minus 28a plus 5, I have that work here. This one right here. So I multiplied the 15 by 5 to get 75. Two factors of 75 that add up to negative 28 would be negative 25 and negative 3. We put them in the middle, and we factor by grouping, and the correct factorization is 5a minus 1 times 3a minus 5. And then 9 minus 4a squared is just the difference of two squares. So once we're done with that, here comes the fun part. We divide through the factors, the factor that appears in the numerator and the denominator. So looking at this, we see that there's a 5a minus 1 up here and a 5a minus 1 down there. So they cancel out. We also have a 5a minus 1 here and a 5a minus 1 here. So they divide through. In addition, we have a 2a minus 3 and a 3 minus 2a, and that divides through to a negative 1. I just realized that I made a mistake in the factorization of 3a squared minus 8a plus 5. And that I put the factors incorrectly. This should be minus 5. I put the numbers in the wrong space. So let me see if I could erase this. Oops, let's see, erase. No. My apologies. The factorization of 3a squared minus 8a plus 5 should be 3a minus 5 times a minus 1. That makes sense because this gives us a negative 5a and a negative 3a that add up to negative 8a. So now we can continue dividing through here. We see that this 3a minus 5 divides through with this one over here in the corner. And this 3a plus 3 plus 2a divides through with the 2a plus 3, which is also a 1 because it's an a plus b over an a plus b or b plus a. And then finally, this factor a minus 1 divides through with a minus 1 to 1. So putting it all together, the final answer is negative 1. So that is the answer to the problem. Okay, I hope this cleared up how to multiply rational expressions, and there are many challenging ones that we could look at as well, but as long as we get the idea. All right, take care now. Bye. We should also write the restrictions for the variable, setting each denominator here on this line to 0, this line here. We get a cannot equal 5/3, 1 when we set a minus 1 to 0, 1/5 when we set the 5a minus 1 to 0, 3/2 when we set the 3 minus 2a to 0, and negative 3/2, setting the 3 plus 2a to 0. So those are the restrictions on the variable, and that takes care of the problem and the lesson. Okay, till next time.